Welcome to Automate Fundamentals. Hi, I'm Luke. In this module, we'll take a look at wideband oxygen sensors, their construction and how they work. The wideband O2 sensor, sometimes referred to as an air-fuel ratio sensor, can have up to 6 wires and is widely used on modern engine management systems. This helps to meet strict emission regulations, increase fuel economy and create better engine performance. They are fitted upstream of the catalytic converter to sample the exhaust gases before conversion. An O2 sensor's job is to measure the concentration of oxygen in the exhaust gas and supply this information to the engine control module, or ECM. The wideband O2 sensor is able to determine the air-fuel ratio because it can determine a much wider range of oxygen concentrations. These sensors are very important on lean burn engines, direct injection petrol and diesel engines. The wideband sensor can measure the air-fuel ratio as rich as 5:1 to as lean as 20:1. You can see here 2 graphs comparing a narrowband sensor and a wideband sensor. It can be seen that the wideband sensor can relay not only rich or lean, but how rich or lean. The sensor's output is a current signal instead of a voltage signal as on narrowband sensors. So what's inside a wideband sensor? These sensors have 3 components: a Nernst cell, an electrochemical pump cell, and a monitoring chamber. The object is to maintain the voltage of the Nernst cell at 450 millivolts. This is achieved by varying the electrochemical pump current flow. The ECU monitors this current and adjusts the air-fuel ratio accordingly. Now we'll go inside the sensor to see how it functions. The exhaust gas enters the vent holes at the end of the sensor. The gases pass through the diffusion gap and enter the pump cell. The Nernst cell will now produce a voltage between 100 millivolts and 900 millivolts, depending on the air-fuel ratio. The monitoring chamber should always be kept at a constant air-fuel ratio of 14.7:1, which will be indicated by a Nernst cell voltage of 450 millivolts. This is achieved by varying the pump cell current. This current has a direct relationship to the air-fuel ratio. If the air-fuel ratio is 14.7:1, there will be no current flowing through the pump cell. If the air-fuel ratio is lean, there would be excess oxygen and the Nernst cell voltage would drop below 450 millivolts. To compensate for this, the pump cell will have a positive current flow, which will reduce the oxygen content in the monitoring chamber. The current flow will be varied to achieve a Nernst cell voltage of 450 millivolts. The ECM will monitor the current flow through the pumping cell and adjust the fuel quantity accordingly. If the air-fuel ratio is rich, the opposite will occur. There would be less oxygen and the Nernst cell voltage would rise above 450 millivolts. To compensate for this, the pump cell will have a negative current flow, which will increase the oxygen content in the monitoring chamber. The current flow will be varied to achieve a Nernst cell voltage of 450 millivolts. The ECM will again monitor the current flow and adjust the fuel quantity accordingly. The ECM can perform a test on the sensor by applying a voltage to the Nernst cell and watching for a response from the pumping cell, as seen here. The wideband sensor needs to be at 650 degrees Celsius or 1200 degrees Fahrenheit. This is achieved by the heater control circuit. The heater is pulse width modulated to maintain the correct temperature. Here you can see a sample pattern of the heater circuit. To diagnose a wideband oxygen sensor requires a scan tool, and if possible, one with graphing mode. The voltage on the scan tool is not a real voltage, but is calculated for display purposes. The voltage range can vary from vehicle to vehicle. This is a comparison between a narrowband and a wideband sensor pattern. The wideband sensor should not be a fluctuating voltage signal like a narrowband sensor. Just like narrowband sensors, a wideband sensor can be tricked by air leaks and leaking injectors, etc. So this needs to be considered when dealing with these sensors. Some causes of a failed wideband sensor can be the failure of the heater circuit or contamination of the sensor by oil, coolant, or the use of incorrect sealants. This concludes our training module on wideband oxygen sensors, what they are and how they work. It's important to understand the differences between oxygen sensors, otherwise you'll find yourself chasing your tail when diagnosing. Remember, keeping up to date with technology is essential in today's automotive industry. Bye for now.